Hello, and a warm, quiet welcome to the Sleepy Story Facts channel. I am so grateful that you have chosen to spend this time here tonight. Perhaps the day has been busy and loud, or perhaps you simply enjoy the feeling of drifting off while contemplating the silent, sparkling vastness of the cosmos. Whatever brought you here, know that this moment is entirely for you. There are no more obligations, no more lists to check, and nowhere else you need to be. You are safe, you are warm, and you are ready to rest. Take a moment to get comfortable. Adjust your pillow, pull the covers up to your chin, and let your eyes gently close. Let your breathing slow down, finding a soft, natural rhythm. Tonight, we are going to embark on a soothing journey through the stars. We aren't here to study or to memorize. We are simply here to observe the beauty of the expanding whole. We will float from one wonder to the next, touching lightly upon ancient mysteries, dark matter, and the silent drifts of deep space. Let these concepts wash over you like a calm wave. If you find these relaxing nighttime stories help you find a place of deep sleep, please do feel free to support the channel so others can find this sanctuary as well. Now, let go of the day. Let us begin our voyage. Let your mind wander back, far back, into the deepest wells of time. We often hear that our universe is approximately 13.8 billion years old. This is the number we have etched into our history books, derived from measuring how fast the galaxies are moving away from us and listening to the faint echoes of creation. Yet the cosmos is a place of infinite mystery, and it may be even more ancient than we realize. There are certain stars burning quietly in distant clusters that appear to be older than that timeline allows. It is a gentle puzzle, a tension between what we measure and what we see. Some astronomers wonder if we have misunderstood how the universe grows, or if the mysterious force of dark energy changes over the eons like the tides of an ocean. These questions remain unanswered, floating in the void. But there is something comforting in that uncertainty. It suggests that what we consider the beginning might just be one chapter in a much longer, stranger, and more beautiful story that has been unfolding forever. As we move through this timeline, imagine drifting past solar systems and glowing nebulas. Out in the deep void between the stars, there are worlds known as rogue planets. These are solitary wanderers, unlike the Earth, which circles the warmth of our sun. These planets float completely alone. They may have been born in a crowded star system, only to be gently pushed away by gravity, sent out to sail the endless ocean of night. Or perhaps they formed in solitude, like stars that never quite ignited. They are dark and cool, silent travelers that are almost impossible to see, visible only when they briefly eclipse the light of a distant star. It is estimated that there are billions of them in our galaxy alone, silent, drifting worlds that will never know a sunrise, existing in a perpetual, peaceful night, accompanied only by the soft glow of the galaxy above them. This idea of endless cycles brings us to another calming possibility. The standard view of cosmology tells us the universe began with a rapid expansion and will continue to drift apart forever. But there is a more rhythmic theory, one that feels almost like breathing. Some scientists imagine a universe that moves in great, slow cycles of expansion and contraction. In this view, the cosmos does not simply fade away into the cold. Instead, after billions of years, it may slow down and draw itself back in, only to bounce outward again in a new creation. It is a concept of infinite renewal. Just as the seasons change and return, the universe itself might be caught in a majestic loop, a heartbeat stretched across eons. One universe gently giving rise to the next, over and over, with no true beginning and no true end. Let us look now for the oldest light we can see. If we look back far enough, we reach a time about 380,000 years after the beginning, when the universe cleared. Before this moment, everything was a hot, dense fog, a glowing mist that trapped light so it could not travel. But as space expanded, it cooled. The fog lifted. Suddenly, light was free to fly across the void. We call this ancient glow the cosmic microwave background. It is still with us today, bathing us in a faint, invisible energy. It is not light from a star, but the afterglow of the universe itself, becoming transparent for the first time. Those particles of light have been traveling for over 13 billion years, stretched out by the growth of space into long, gentle waves. It is a quiet, omnipresent relic, a memory of clarity from the dawn of time. In this vastness, chemistry creates wonders that seem like dreams. Imagine a solar system far from here, where a planet is made not of rock or gas, but of crystal, in environments rich with carbon and crushed by immense pressure. Astronomers believe worlds can form that are essentially diamond. There is at least one such world orbiting a collapsed star, a dense remnant of a sun. This planet is so compressed and carbon-rich that deep below its surface, the carbon has crystallized. It is a world of diamond, thousands of kilometers deep. It wouldn't look like a sparkling engagement ring. It is dark and hot, a hidden jewel wrapped in the silence of space. It serves as a reminder that the universe is capable of forming almost anything we can imagine, from clouds of gas to spheres of pure crystal. Finally, for this part of our journey, consider the shape of space itself. We naturally want to imagine that the universe has an edge, a wall where everything stops. But nature is rarely so abrupt. Just as a traveler on Earth can walk in a straight line and never fall off the edge, eventually returning to their starting point, the universe may be similar. Current theories suggest space is either infinite, stretching on forever, or it is curved back upon itself. If you could travel in a starship in a perfectly straight line for long enough, you might not hit a wall. You might simply circumnavigate the cosmos, wrapping around the curvature of reality to arrive back home. It is a loop without borders, a vast, comforting enclosure where there is no end to the journey, only endless space to drift and dream. It is not infinite in barriers, but infinite in the journey itself. As we drift deeper into this relaxing nighttime story, let your mind float toward our own home star, the sun. It sits alone in our sky, a steady, solitary guardian of our days. But it is possible that it was not always this way. Many astronomers believe that billions of years ago, in the nursery of gas and dust where our solar system was born, the sun had a twin. It is a beautiful thought, two stars forming together, a pair of siblings lighting up the early dark. Stars are often born in pairs or clusters, huddling together before the galaxy pulls them apart. If our sun did have a companion, it has long since drifted away, carried off by the slow, gentle currents of the Milky Way. It would be out there now, somewhere in the vast distance, circling the galactic center on a lonely path of its own. We cannot see it, and we may never find it, but the idea lingers like a soft memory. Our sun, which feels so singular to us, may have once shared its warmth with a silent partner, now lost to the peaceful, velvet depths of space. From the drifting stars, let us turn our thoughts to something incredibly still and heavy. Imagine the concept of weight, of being grounded and held down. In the universe, there are remnants of old stars known as neutron stars. These are the cores left behind when a massive star finishes its life and collapses inward. These objects are small, perhaps only the size of a city, but they are incredibly dense. The matter inside them is packed so tightly that the atoms themselves have been crushed together. Protons and electrons merging into a calm, dense soup of neutrons. To understand this density, imagine a single raindrop made of this material, just one small, glistening drop. If you could bring that drop to Earth, it would weigh more than Mount Everest. It is a heaviness that defies our imagination, a kind of absolute solidity. These stars spin rapidly in the dark, but their mass is a quiet anchor in the fabric of space-time, a place where matter has become nearly pure gravity, heavy and unmoving. Light, too, has its own strange journey. We tend to think of light as a straight arrow cutting through the dark. But in the deep universe, light is more like a traveler walking a winding path. When light from a very distant galaxy passes near a massive object, like a cluster of other galaxies, the gravity of that cluster acts like a lens. It curves the fabric of space itself. The light follows this curve, bending like a stream of water flowing around a smooth stone. This is called gravitational lensing. Because of this, the light might take 2 or 3 different paths to reach us. When we look through our telescopes, we might see the same distant galaxy appearing in multiple places at once, like a reflection in a funhouse mirror. It is not a duplicate galaxy. It is simply the same light, arriving at different times after taking different roads through the cosmos. It is a reminder that in this vast sleep story of the universe, even light can wander, taking the scenic route before finally finding its way home to our eyes. Long before our sun or these bending lights existed, there were the first stars. Let your imagination drift back to the very beginning. Just after the fog of the early universe cleared, these ancestors of the night sky were likely very different from the stars we see tonight. Made of pure hydrogen and helium, they were massive, burning with a fierce and brilliant intensity. They were the torchbearers of the cosmos. Because they were so huge, they burned through their fuel quickly, living for only a brief spark of cosmic time. But in their short lives, they changed everything. They forged the first heavy elements, filling the empty void with the ingredients for future worlds. They are gone now, vanished into the dark, but their legacy remains in every atom of our world. They were the first to wake up the universe, filling the silence with a brilliant golden light. And as you lie there, safe in your bed, consider the invisible river that flows around you. We call it dark matter. It is a mysterious substance that we cannot see or touch, yet it makes up the framework of the galaxy. It does not reflect light or cast a shadow. It simply exists, holding the spinning galaxies together with its gentle gravitational pull. As the Earth moves through space, it moves through a sea of this invisible matter. At this very moment, streams of dark matter are likely passing effortlessly through your room, through your walls, and even through you. It is a comforting thought, in a way. You are transparent to the universe. These particles do not bump into you. They do not disturb your rest. They simply flow, a silent, ghostly stream that connects you to the deepest structures of the cosmos. You are part of the great flow of things, held in the arms of a universe that is mostly invisible, yet always present in the quietest corners of space. There are even galaxies that seem to prefer the dark. Astronomers have found strange, ghostly systems that contain almost no stars at all. These are dark galaxies. They are vast clouds of gas and dark matter swirling in the void, but they have not lit up with the fires of star formation. They are like sleeping giants. Perhaps they lost their stars long ago, or perhaps they simply never woke up. They float through the vacuum, invisible and silent, detected only by the faint way they interact with the space around them. They challenge our ideas of what a galaxy should be. We usually imagine swirling pinwheels of light, but the universe is diverse. It has room for bright, busy places, and it has room for these quiet, shadowy drifts, places of pure rest, where the lights are kept low and the night is eternal. Finally, for now, let us look at the map of the ancient universe one more time. In the smooth, warm glow of the cosmic background, there is a specific patch that is different. It is known as the cold spot. It is a vast area of the sky that is significantly cooler than everything around it. It is a mystery that has puzzled scientists for years. It is not chaotic or frightening. It is simply a cool breeze in the heat of the early universe. Some think it might be a supervoid, a purely empty space stretching for millions of light years. Others wonder if it is a gentle bruise from when our universe might have brushed against another in the very first moments of its expansion. Whatever it is, it sits there in the data, a quiet anomaly. It is a reminder that even in the laws of physics, there are surprises. There are cool, quiet places where the rules seem to soften, inviting us to wonder and inviting us to sleep. The moon, our faithful companion in the night sky, is slowly drifting away. It is a departure so gentle and gradual that we could never see it with our own eyes. Every single year, the moon moves about 3.5 centimeters further from the Earth. It is a tiny distance, roughly the same speed at which your fingernails grow. Yet, this slow, silent retreat has been happening for billions of years. Ever since the moon first coalesced from the dust of the early solar system. In those ancient days, the moon hung huge and close in the sky, and the Earth spun so quickly that a day lasted only a few hours. The reason for this drift is a soft exchange of energy called tidal friction. As the moon's gravity pulls on our oceans, creating the tides, The Earth's rotation pushes back ever so slightly, nudging the moon into a wider orbit. It is a quiet, relentless dance, a slow-motion farewell that will continue for eons. Eventually, in the distant future, they may lock together in a perfect, unchanging gaze. But for now, the moon simply slips away, little by little, casting its pale light over us as we sleep in the vast dance hall of the cosmos. Binary stars sometimes move like partners in a waltz, so close they can almost touch. Imagine two stars locked in a gravitational embrace, spinning around one another. Sometimes they drift so near that their outer atmospheres begin to brush against each other. It is a delicate exchange. Matter from one star can spill softly onto the other, creating a spiraling bridge of light between them. Sometimes this transfer is calm and steady, a silent sharing of substance. Other times, it sparks sudden flares or changes the speed of their spin. It is a complex physical process, but in our minds, it is simply graceful. Two ancient suns, swirling in the dark, blending their light and their fates. One might give away its outer layers to become a small, glowing core, while the other grows bright and enriched. It reminds us that even in the cold vacuum, there is connection, sharing, and a kind of cosmic closeness. We often think of deep space as an empty void, a perfect nothingness, but science tells us that even the purest vacuum is alive with hidden energy. Even in the deepest gaps between the galaxies, far from any sun, the silence is not truly empty. According to quantum physics, the vacuum is a shimmering sea of potential. Tiny particles blink into existence and vanish again in the span of a nanosecond. A constant, restless hum beneath the surface of reality. These are called quantum fluctuations. They are happening everywhere, all the time. A subtle heartbeat of the universe that we can never see. This hidden activity might even be the source of dark energy, the force pushing the universe apart. So when you picture the dark quiet of space, know that it is not a dead silence. It is a living stillness, a vibrant, invisible ocean of possibilities, rippling just beneath the calm surface of the night. Time itself is not a rigid ticking clock, but a flowing river that changes speed depending on where it travels. We tend to feel time as a steady, unchangeable rhythm. 1 second is always 1 second, but out in the cosmos, time is flexible. It is woven together with space and gravity. Near massive objects, like giant stars or black holes, gravity pulls on the fabric of reality so hard that time actually slows down. A minute there would be much longer than a minute here. This has been proven by our most precise clocks and satellites. It leads to a wondrous question. Does time flow differently in the far reaches of the universe? Could the history of the cosmos be slightly different depending on where you are standing? It suggests a universe where time is not a strict rule, but a gentle, variable current, slowing and stretching as it winds through the deep valleys of gravity. Our own home, the Milky Way, is much larger and more mysterious than it appears in pictures. When we see paintings or photos of our galaxy, we see the beautiful, glowing spiral arms where the stars live. But that bright spiral is just the center of something much vaster. Surrounding the visible galaxy is a massive, invisible sphere known as the galactic halo. It is a huge envelope of gas and dark matter that extends far out into the darkness, dwarfing the spiral disk we call home. This halo is like a protective shell, holding ancient star clusters and silent, drifting matter. It is held together by gravity, a remnant of the galaxy's long history of growth. Though we cannot see it with our eyes, we know it is there by the way it guides the stars. We are living in the bright heart of a much larger, unseen structure, wrapped in invisible arms that stretch out into the night. We have managed to catch a glimpse of a ghost from the very beginning of time. Through our most powerful telescopes, we have detected light from a galaxy that existed when the universe was only a child. The universe is billions of years old, and light takes time to travel across it. This means looking into deep space is literally looking back in time. Recently, astronomers found a faint smudge of light from a galaxy that formed just 200 million years after the Big Bang. That light has been traveling through the expanding dark for over 13.5 billion years to reach us. It is a small, primitive galaxy, a tiny island of stars in the early dark, but seeing it is like looking through a keyhole into a forgotten era. It is a message from the dawn of creation, a soft glow that has survived the entire history of the cosmos just to reach us now. Finally, consider the shape of everything when we zoom out as far as possible. The structure of the universe begins to look strangely familiar. If you map the positions of millions of galaxies, you don't see a random scatter of dots. You see a web. Galaxies cluster together in long, thin filaments, separated by giant voids of empty space. It looks like a vast, three-dimensional lace stretching across the dark. This is the cosmic web, and remarkably, it looks almost exactly like the neural networks inside the human brain. The bright clusters of galaxies look like neurons, and the filaments look like the connections between them. The universe is not thinking, of course, but there is a profound beauty in this resemblance. The largest structure we can observe and the delicate structure of our own minds share the same intricate, woven pattern. As above, so below, a universe of connections, mirroring the thoughts drifting through your mind as you fall asleep. As we drift further into this sleep story, let your imagination listen to the silence of space. We often think of the cosmos as a place of absolute quiet, a vacuum where sound cannot travel, but in a way that is both strange and beautiful. The stars are singing. Deep inside every star, including our own, there are slow, rhythmic vibrations. These are not sounds that travel through air like a voice, but deep pressure waves that ripple through the star's glowing interior. They move like slow tides in a sea of light. These waves cause the star to pulse and shimmer, expanding and contracting in a rhythm that is unique to each one. Scientists call this asterosismology, the study of stellar songs. Each star hums with its own specific frequency, a cosmic fingerprint determined by its age and its size. It is a form of music that plays across the light years, a deep, resonant lullaby that we cannot hear with our ears, but can see in the gentle twinkling of the night sky. The universe is filled with this silent choir, singing softly to the dark. Within the great spiral of a galaxy, there are sometimes travelers that are older than the home they inhabit. Galaxies are not built in a single day. They grow slowly over eons, merging with smaller clouds and gathering wandering stars. Because of this, some of the stars shining in the outer edges of a galaxy are actually ancient survivors. They were born in different, smaller systems long before the current galaxy took shape. These stellar elders often live in tightly packed groups called globular clusters, floating like halos around the galaxy's center one. Some of these stars are nearly as old as the universe itself, burning quietly for over 13 billion years. They are like fossils of light, carrying the memory of a younger, simpler cosmos. They have watched the galaxy grow up around them, silent witnesses to a history that stretches back to the very first fires of creation. While dark matter is usually the invisible glue that holds the universe together, there are strange exceptions that float freely. Astronomers have recently found a few rare galaxies that seem to be light as air, cosmically speaking. These galaxies appear to contain almost no dark matter at all. In most places, dark matter is the heavy, unseen hand that keeps stars from flying away. But in these airy galaxies, the stars drift along using only their own gravity, moving slowly and gracefully. It is a mystery that defies our current understanding. Perhaps they lost their dark matter in a gentle collision long ago, or perhaps they formed in a way we have not yet dreamed of. They serve as a reminder that the universe is not rigid. It is full of exceptions, full of floating anomalies that suggest there is still so much magic left to discover in the deep, velvet night. Let us return to the source of our own warmth. The sun, our golden star, is not just a ball of fire. It is a giant, ringing bell. Just like the distant stars, our sun is filled with sound waves generated by the turbulence of its hot plasma bounce around inside it, striking the surface and reflecting back down to this causes the entire sun to vibrate. It rings with a rhythm that is far too low for human ears to hear, a deep, booming resonance that cycles over minutes and hours. By watching these ripples, scientists can map the inside of the sun, seeing rivers of hot gas flowing beneath the surface. It is a comforting thought to imagine the sun not just as a lamp, but as an instrument, humming a steady, life-giving note that vibrates through the solar system, holding us in its warm, rhythmic song. On the grandest scales, the universe is built like a delicate necklace. The galaxies do not float randomly. They are strung together along invisible bridges. These are filaments of dark matter, long, thin threads that stretch across millions of light-years. 3 galaxies tend to form and flow along these filaments, looking like glowing pearls. Sliding along a hidden string-4 between these filaments are the great cosmic voids, vast bubbles of empty space where very little exists. 5. This structure creates a hidden scaffolding for the universe. We cannot see the threads, but we see the galaxies tracing their paths. It is a vast, interconnected web, holding the heavy clusters of stars in place, shaping the flow of the cosmos in the dark 6. There is a concept in physics that sounds impossible, but in the soft logic of the universe, it is simply the nature of space. Space can stretch faster than light. We are told that nothing can travel through space faster than the speed of light. But space itself is not a thing that travels. It is the canvas. And that canvas can stretch at any speed it chooses in the very early universe, and even now in the farthest reaches. The space between galaxies expands so quickly that it carries them away from us faster than their light can reach us. It is not a violent race. It is a gentle, relentless widening of the horizon. These distant worlds are simply drifting over the edge of our visibility, carried by the calm, ceaseless expansion of the universe. It is a reminder that there are things beyond our reach, drifting into a quiet forever where we cannot follow, and that is okay. Finally, for this moment, visualize the movement of our own home. We are on a journey we rarely perceive. We are taught that the planets orbit the sun in flat, perfect circles. But this is only part of the story. The sun itself is moving, sailing through the Milky Way at tremendous speed 7, because the sun is moving. The planets are not just circling, they are chasing it. If you could trace our path from far away, you would not see flat rings. You would see a beautiful helical spiral. The solar system is like a corkscrew or a twisting ribbon, boring a path through the galaxy. We are never in the same place twice. Every moment, even as you sleep in your bed, you are traveling through new space, spiraling endlessly forward in a graceful, coiling dance among the stars. It is a dance so vast we never feel it, a movement that carries us safely through the night. And as we travel, even the emptiness around us holds a secret warmth. If you were to drift far away from the Earth, past the sun, and beyond the edges of the galaxy, you would find yourself in deep intergalactic space. It looks like pure nothingness. But even here, in the deepest void, there is a temperature. It is about 2.7 degrees above absolute zero. This faint, pervasive warmth is the cosmic microwave background. It is the lingering breath of the Big Bang, the afterglow of creation that has been cooling down for billions of years. It fills every corner of the universe like a soft, invisible blanket. It is a quiet reminder that space is never truly cold or dead. It holds the memory of the first heat, a gentle thermal signature that will slowly cool over trillions of years, approaching a perfect, frozen stillness. If we look at the very largest structures in the sky, we find that they were born from the very smallest shivers of reality. Long ago, when the universe was new, it was smaller than an atom. In that tiny state, quantum physics ruled. Energy flickered and wobbled in random, tiny fluctuations, little blips of uncertainty. Then, the universe expanded. It grew so fast that these microscopic shivers were stretched out across light years. The great galaxies, the vast voids, and the glittering filaments we see today are simply those tiny, ancient trembles grown up. The grand architecture of the cosmos, the places where stars ignite and worlds form, all trace back to a fleeting ripple in the fabric of nothingness. Everything we are began as a whisper in the dark. Out in that darkness, some stars breathe. While our sun shines steadily, there are other suns, known as variable stars, that pulse with a slow, rhythmic beat. These stars swell and shrink over time, expanding their outer layers and then drawing them back in. As they change size, their light dims and brightens, repeating a cycle that can last for days or months. It is like watching a star breathe. It is a cosmic lung, inhaling and exhaling light into the vacuum. Astronomers use these rhythmic pulses to measure the size of the universe. But for us, tonight, they serve a different purpose. They remind us that the universe has a pulse. Even in the silence of space, there is a steady, comforting rhythm, a heartbeat of light that keeps time while we rest. Closer to home, we find that we are resting inside a protective shell. If our eyes could see the heat of gas in space, we would realize that our entire solar system is floating inside a giant bubble. It is called the local bubble. It is a vast cavity of thin, hot gas stretching for hundreds of light years. It was likely carved out millions of years ago by ancient stars that exploded and pushed the surrounding dust away. Now, we drift quietly through the clear space they left behind. It is a low-density cavern in the galaxy, a quiet clearing in the cosmic forest. We are safe inside this bubble, drifting through a calm patch of the Milky Way, sheltered by the history of stars that came before us. On a much larger scale, our galaxy is caught in a gentle tug-of-war that spans the universe. We are drifting toward a massive region known as the Great Attractor, pulled by its immense gravity. But behind us, there is something else, a vast region of emptiness called the Dipole Repeller. This is a cosmic void, a place with very few galaxies. And strangely, this emptiness seems to push us away. It is not a violent shove, but a subtle guidance. The presence of matter pulls us forward, and the absence of matter pushes us from behind. We are caught in a great, invisible current, flowing like a leaf on a slow river, guided by the landscape of the universe itself. It is a reminder that even emptiness has power, shaping our path through the dark. As you lie there, stillness is an illusion. You are currently being visited by ghostly travelers from the stars. At this very second, trillions of tiny particles called neutrinos are passing through your body. They come from the sun, from distant exploding stars, and from the beginning of time. They are incredibly small and light. They barely interact with anything. To a neutrino, the Earth is as transparent as a window pane. They fly through the planet, through your walls, and through you without ever slowing down. They do not touch your atoms. They leave no trace. They simply flow. You are permeable to the universe. It is a peaceful thought to let these harmless, silent particles stream through you, connecting you to the fusion of the sun and the depths of space without ever disturbing your sleep. We often think of stars ending their lives in brilliant, loud explosions. But sometimes, the universe prefers silence. For the most massive stars, the end can be a sudden, quiet vanishing. When such a star runs out of fuel, its core is so heavy that gravity takes over completely. Instead of bouncing back into an explosion, the star simply collapses inward. It folds into itself, crossing the event horizon in a blink. One moment, there is a star. The next, there is only a black hole. No fireworks, no sound. The light simply turns off. It is a direct collapse, a gentle exit, where the star slips seamlessly into the shadows. It is the ultimate form of rest, a transition from brilliance to eternal, quiet darkness. Finally, remember that even galaxies get lonely, and so they find companions. We tend to picture galaxies as solitary islands, but many of them orbit one another. Our Milky Way is accompanied by dozens of smaller satellite galaxies, such as the Magellanic Clouds. These smaller galaxies circle us like moons orbiting a planet. They trace long, slow ellipses through the dark, dancing with our galaxy over billions of years. Sometimes they get close enough to share stars, trailing streams of light between them like held hands. It is a slow, graceful waltz on a scale we can barely comprehend. In the vast quiet of deep space, nothing has to be truly alone. Even the galaxies keep each other company, turning together in the endless, peaceful night. From the gentle dance of galaxies, let us turn our thoughts to the sources of immense brilliance. Even in the deepest sleep of the cosmos, there are moments of light that defy description. We know that stars have magnetic fields, just as Earth does. But there is a rare kind of star, known as a magnetar, where these fields are trillions of times stronger than anything we know on. When one of these heavy, magnetic stars reaches the end of its life and collapses, it creates something truly breathtaking, a hypernova. It is perhaps the brightest event the universe can produce. For a few fleeting seconds, this single collapsing object can outshine an entire galaxy of billions of stars too. It releases a burst of pure energy that travels across the vastness of space, touching us even from billions of light years away. It is not a frightening event, but a testament to the power of nature. It is a flash of pure, magnetic light in the deep dark, a silent firework that marks a transition in the life of the cosmos. As we look out at these lights, we eventually reach a limit. This is known as the edge of the observable universe. It is important to remember that this is not a wall. There is no barrier at the end of space. It is simply a horizon, because light takes time to travel, and the universe has only existed for a certain amount of time. We can only see about 46 billion light years in any direction. This is our bubble of vision. Beyond this horizon, the universe likely continues on, endless and vast, filled with more galaxies and more stars that are simply too far away for their light to have reached us yet. Because space is expanding, those distant regions are moving away from us faster than the light can travel. They are drifting into a permanent mystery, forever beyond our view. It is a comforting thought that reality is larger than what we can see, a vast, unmapped territory that belongs only to itself. In the center of some of these distant galaxies, there are fountains of energy that span millions of years. We often think of black holes as objects that only consume, drawing everything in. But nature is complex. As matter swirls toward a supermassive black hole, not all of it falls in. Some of it is caught by powerful magnetic lines and redirected, shot outward into the void in two magnificent jets. These are streams of plasma moving at nearly the speed of light. They can stretch far beyond the galaxy itself, reaching out into the intergalactic silence for millions of light years. Astronomers call them radio galaxies. They are like cosmic lighthouses, beaming vast lobes of energy into the dark. It is a strange and beautiful irony. The places where gravity is strongest can also produce the largest, most graceful structures in the universe. fountains of light rising from the deep, closer to home. Within the swirling clockwork of our own Milky Way, there is a star that refuses to follow the crowd. Almost every star in our galaxy orbits the center in the same direction, flowing like water in a river. But astronomers have found a star that moves the other way. It is on a retrograde orbit, moving against the flow, like a salmon swimming upstream, or a traveler walking their own path against a crowd. How it got there is a mystery. Perhaps it was once part of a smaller galaxy that merged with ours long ago, and it simply kept its old path. Or perhaps it was flung there by the gravity of a black hole. Whatever its history, it is a quiet wanderer. It reminds us that there is no single right way to move through the universe. Even in the strictest systems, there is room for the solitary traveler, the star that goes its own way. And if we could travel to the center of our galaxy, we might find that it appeals to more than just our eyes. It might actually appeal to our sense of smell. It sounds like a dream, but it is true. In the vast dust clouds near the heart of the Milky Way, astronomers have identified a molecule called ethyl formate 3 on Earth. This specific chemical is responsible for the flavor of raspberries and the smell of rum. Of course, space is a vacuum. We could not breathe it in. But the chemistry is there, floating in the silence. The center of the galaxy contains the seeds of sweetness and warmth. It is filled with alcohols, sugars, and the building blocks of life, swirling in the dark clouds. It paints a picture of a universe that is not just cold rock and gas, but a place rich with potential, smelling faintly of fruit and old spirits, waiting for life to begin. We often speak of the future, but one major event has already begun in slow motion. Our galaxy is touching its neighbor. The Andromeda Galaxy is spiraling toward the Milky Way. We are destined to meet. But this is not a crash, it is a merger, a graceful blending of two great systems. While the bright spirals are still millions of light years apart, the vast, invisible halos of gas that surround both galaxies have already begun to overlap. We are already shaking hands. Over the next 4 billion years, the two galaxies will pass through one another, their stars missing each other in the vast spaces, gradually settling down to become one large elliptical galaxy. It is a cosmic union, a marriage of billions of stars playing out over eons, turning two swirls of light into one. Finally, let us return to the light that surrounds you right now. As we mentioned at the start of our journey, the cosmic microwave background is everywhere. It is worth repeating because it is the most comforting blanket in existence. The afterglow of the Big Bang, that first flash of freedom when the universe cooled, has never left us. It has been stretched by the expansion of space until it became invisible microwaves. But it is still there, in the room where you sleep, in the sky above your roof, and in the deep space between the stars. The universe is filled with a uniform, gentle glow. It is a fossil of the first light, a steady, unchanging signal that whispers of our origins. You are never in total darkness. You are always held within the faint, ancient light of the universe's beginning, a soft glow that has persisted for eternity, watching over you as you drift into dreams. We have talked about light, but the universe also has a profound appreciation for shadow. Some of the most powerful events in the cosmos happen without a single photon reaching our eyes. Usually, when a massive star dies, it goes out in a blaze of glory, a supernova that lights up the galaxy. But there are times when a star decides to keep its final moments private. These are known as failed supernovae. In these rare, quiet cases, the core of the star collapses so quickly and so completely into a black hole that the outer layers do not explode outward. Instead, they simply fall in. The star swallows itself. One moment, a bright point of light is there; the next, it is simply gone. No flash, no fading ember, just a sudden, silent exit into the dark. It suggests that immense power does not always need to be loud. Sometimes, the most profound changes happen in absolute silence, hidden behind a curtain of gravity. Drifting through the deep dark, there are also entire galaxies that have chosen to remain dim. We are used to seeing galaxies as bright, spiraling fireworks, filled with billions of blazing stars. But out in the void, there are dark galaxies made almost entirely of gas. And that mysterious substance, dark matter, these systems are ghosts. They have mass, they spin, they exist, but they have very few shining stars to mark their presence. They appear in our telescopes only as faint smudges, like fingerprints on the lens of the universe. Perhaps they never managed to ignite enough stars, or perhaps they are still waiting for their time to shine. They float quietly, subtle giants of gas and gravity, proving that you do not need to sparkle to be real. You can simply exist, heavy and calm, in the quiet of the night. And when the darkest objects in the universe meet, they do not crash, they dance. Imagine two black holes, invisible titans, finding one another in the deep. As they spiral closer, they begin a gravitational waltz. They do not emit light, but they ripple the very fabric of reality. As they finally merge, becoming one larger silence, they send out a pulse of gravitational waves. These are not sound waves, but tremors in space-time itself. In 2015, our instruments on Earth felt one of these tremors for the first time. A tiny, rhythmic wobble from a merger that happened over 1 billion years ago. It was a message sent across the cosmos, a signal that even in the darkest mergers, the universe sings a low, vibrating note that travels forever. For smaller stars, like our own sun, the end is not a sudden disappearance or a violent crash. It is a slow, gentle fade that lasts for eons. When a star like ours runs out of fuel, it will puff out its outer layers, creating a beautiful cloud of glowing gas. What is left behind is a white dwarf, a small, dense core that is no longer burning. It is like a cosmic coal left in the fireplace after the fire has gone out. It glows simply because it is still warm. Over billions of years, it will slowly cool down, dimming from white to yellow, to red, and finally to black. This cooling takes so long that the universe is not yet old enough for any white dwarf to have gone completely dark. Every single one that has ever been born is still out there, glowing softly, fading in slow motion. It is a peaceful resignation, a gentle twilight that stretches on for longer than we can comprehend. In the presence of great gravity, time itself decides to rest. Einstein taught us that gravity bends everything, including time. The closer you are to a massive object, the slower time moves. Near a black hole, this effect becomes extreme. If you were to orbit just outside the event horizon, you would be moving through time at a different pace than the rest of the universe. A few minutes for you might be years or decades for someone far away. It is not a trick, it is the nature of reality. Gravity stretches the moments, pulling them out like taffy. It creates a pocket of stillness where the rush of the universe slows down, offering a strange kind of eternal present, suspended in the dark. Between the islands of light we call galaxies, there are vast oceans of cold. The spaces between galaxies, the cosmic voids, are some of the loneliest and coldest places in existence. Far from the warmth of any star, the temperature drops to just a few degrees above absolute zero. It is a deep, penetrating chill born from emptiness. There is almost nothing there to hold heat, just a few stray atoms drifting alone in the dark. These voids span millions of light years, silent and still. They are the resting places of the universe, the empty canvases between the art. They hold only the faint whisper of the cosmic background, a silence so profound it feels like a heavy blanket of peace. Finally, consider the clarity of the night. As the universe ages, it is becoming clearer. In its infancy, the cosmos was a thick, hot fog. Light was trapped, bouncing around in a chaotic storm of particles. But as the universe expanded and cooled, the fog lifted. Atoms formed, and space became transparent. Light was free to travel. This process has continued ever since. As galaxies form and matter clumps together, the vast spaces between them become emptier and clearer. The universe is slowly cleaning its own windows. With every passing epoch, the view gets a little sharper. The light travels a little further without interruption. The darkness is not becoming heavier. It is becoming more open, allowing the light to pass through unimpeded. A vast, crystal-clear ocean of night waiting for you to dream. We have managed to take a picture of the unseeable. In 2019, humanity did something profound. We captured an image of a black hole's shadow. Deep in the center of the galaxy M87, some 53 million light years away, there is a monster of gravity. We cannot see the black hole itself, of course, for it consumes all light, but we can see the golden ring of hot gas swirling around it, outlining its silhouette. It looks like a glowing eye in the dark. To capture this, we did not use just one telescope. We connected telescopes all over the Earth, turning our entire planet into one giant lens, all looking up at the same time. It was a quiet triumph of cooperation. It gave us our first true glimpse of the abyss, not as a terrifying void, but as a beautiful, circular shadow, haloed by the light of a distant galaxy. You do not need a planet-sized telescope, however, to touch the edge of the universe. You only need your eyes. If you stand outside on a clear, dark night in the northern hemisphere and look up, you can see a faint, fuzzy oval in the sky. That is the Andromeda Galaxy. It is over 2.5 million light years away. The light hitting your eyes left that galaxy before humans even walked the Earth. It is a neighbor, a swirling island of a trillion stars that is slowly drifting toward us. It is difficult to truly comprehend. but it is there. You can stand in your backyard, feel the cool night air, and look directly at an entire galaxy with no equipment at all. Just you, the silence, and the soft, ancient glow of a trillion suns drifting in the dark. Sometimes, the universe speaks in whispers. In 2015, we heard one. A delicate instrument called LIGO detected a tiny ripple in the fabric of space-time. It was a gravitational wave over 1 billion years ago. Two black holes collided in the deep dark. They did not make a sound, and they did not make a flash. But their collision was so powerful that it shook the texture of space itself. That ripple traveled across the universe for eons, finally washing over the Earth like a gentle wave on the shore. It stretched and squeezed our planet by less than the width of a single proton. But we felt it. It was a cosmic chirp, a faint signal confirming that even in the vast silence, massive events send out ripples, connecting us to the deepest movements of the night. As we drift further, we must accept that the universe is practicing the art of letting go, because space is expanding, and that expansion is speeding up. Some distant galaxies are being pushed away from us faster than light can travel. They are crossing a cosmic horizon, a point of no return. Their light will never reach us again. They are slipping into the unobservable, fading gently from our view forever. It is not a tragedy. It is simply the nature of things. The universe is growing, and in doing so, it is allowing parts of itself to drift into solitude. The visible world is slowly shrinking, leaving us with a sky that is becoming quieter, simpler, and more peaceful over billions of years. Before there were stars to drift away, there may have been silent seeds. Most black holes are born from dying stars. But some scientists believe there are primordial black holes, ancient knots of gravity that formed in the first second after the Big Bang, before any light shone. Pockets of matter may have been squeezed so tight they collapsed. If they exist, they are older than the galaxies, older than the stars. They would be silent fossils from the very beginning of time, floating unseen through the cosmos. They are the heavy, quiet anchors of history, drifting through the vacuum since the moment the clock started ticking. There are also invisible threads that bind the cosmos together. In the strange world of quantum mechanics, two particles can become entangled. This means they share a connection that distance cannot break. If you change one, the other responds instantly. Even if they are on opposite sides of the universe, it is as if they are holding hands across the dark. Some theories suggest that these connections are what stitch space together, weaving the fabric of reality. It is a beautiful thought to end on, that nothing is truly separate. Even across the widest voids, there are invisible links, quiet echoes connecting the dawn of time to this very moment. And even empty space is not truly empty. It is filled with a potential called vacuum energy. If you could remove every star, every atom, and every ray of light from a box, the space inside would still have energy. It hums with tiny fluctuations, a restless ocean of quantum activity. This is the pressure of nothing. As the universe grows, this energy does not dilute. It stays constant, pushing the cosmos apart. It is a strange paradox. The more nothing you have, the more power it holds. The silence of space is not a lack of things, it is a presence, a force that gently drives the expansion of the world. Finally, we arrive at the longest fade of all. We used to think black holes were eternal, but we now know they eventually return to the light. Through a process called Hawking radiation, black holes slowly lose energy. They glow with a very faint heat. Over timelines that are impossible to imagine, trillions upon trillions of years, they will slowly evaporate. They will shrink, giving their energy back to the universe until they simply fade away. It is the quietest kind of ending. No destruction, no sudden stop. Just a long, slow, peaceful fade into the background of eternity. As we continue to float through this relaxing nighttime story, let us reconsider what the universe is actually made of. Here on Earth, we are used to solid ground beneath our feet, liquid water in our cups, and the invisible air we breathe. But out among the stars, matter takes a different, more fluid form. The most common state of matter in the cosmos is plasma. It is not quite a gas and not quite a fire, but a glowing cloud of charged particles where electrons roam free. It is the stuff of stars, the substance of the solar wind, and the faint, glowing mist that fills the spaces between galaxies. In fact, most of the visible universe is made of this shimmering material. While we rarely see it on Earth, except in the flash of lightning or the warm hum of a neon sign in space, it is everywhere. It flows like a river of light, responding to magnetic fields, carrying currents across the dark. It paints a picture of a universe that is not rigid or hard, but glowing, flowing, and alive with energy. And through this glowing medium, ripples are constantly moving. We have spoken of gravitational waves, those tiny shivers in space-time caused by the movement of massive objects. It is fascinating to realize that these waves travel at a very specific speed, the speed of light. When two neutron stars collide in the deep dark, the ripple they create races outward at the fastest speed the laws of physics allow. It does not happen instantly. It travels, crossing the void like a message in a bottle. These waves stretch and squeeze the fabric of space as they pass, a silent, invisible pulse. We cannot hear them with our ears, but they are there, gentle tremors passing through the earth, carrying the story of distant events, reminding us that the universe is connected by a fabric that can move, shake, and settle back into stillness. If you were to step back and look at the universe from a great distance, you would see a pattern of breathtaking beauty. Galaxies are not scattered randomly like dust. They are woven together. They gather along vast, invisible threads of dark matter and gas, forming a structure known as the cosmic web. It looks like a giant, three-dimensional lace. Where the threads cross, great clusters of galaxies bloom like knots of light. Between the threads lie the cosmic voids, immense, quiet bubbles of emptiness. It looks remarkably like the delicate veins of a leaf or the neural pathways of a mind. It suggests that the universe has an architecture, a grand design that is not built, but grown, a vast, interconnected lattice, holding the stars in its gentle grip. In this vast web, we have built tools to see ghosts. The James Webb Space Telescope was designed to look further than we have ever looked before. But in astronomy, Looking far away means looking back in time, because light takes billions of years to cross the cosmos. We are never seeing the universe as it is right now. We are seeing it as it was. Some of the distant galaxies we capture in our images may have faded away eons ago. They might have merged with neighbors or changed shape entirely. But their light is still arriving, a beautiful, delayed letter from the past. Every deep field image is a gallery of ancient history, a collection of moments frozen in amber, allowing us to witness the childhood of the universe while we rest in its present. Think of the journey that light has taken to reach your eyes. When you look at a speck of light from a distant galaxy, you are connecting with something older than the Earth itself. The photons striking the mirror of a telescope may have begun their journey more than 10 billion years ago. At the moment that light left its home, our sun did not exist. There was no Earth, no moon, no solar system, only a cloud of potential gas. That light has been traveling through the silence of space for all that time, crossing the expanding void, just to arrive here tonight. It is a humbling thought. The night sky is not just a ceiling. It is a deep well of time, and every star is a memory. Sometimes the universe wears a veil. Not everything in the sky is visible to the naked eye. There are entire galaxies hidden behind thick curtains of interstellar dust. These are not like the dust in a room. They are vast, cold clouds of carbon and silicate grains drifting through space. They block visible light, hiding the treasures behind them. But just because we cannot see them with our eyes doesn't mean they aren't there. When astronomers look with infrared cameras, the heat of the hidden galaxies shines through the dust, revealing shimmering spirals and bright cores that were waiting in the dark. It is a comforting reminder that darkness does not mean emptiness. Sometimes it is simply a cover, a warm blanket hiding wonders until the time is right to see them. Occasionally, gravity plays a trick on our eyes, creating a perfect illusion. When a massive galaxy sits directly in front of a distant light source, its gravity acts like a lens. It bends the light coming from behind it, warping it into a circle. This is called an Einstein ring. It looks like a perfect, glowing halo suspended in the darkness. It is a rare and beautiful alignment, a ring of fire created not by a star, but by the curvature of space itself. These rings are silent, static loops of light, enduring for millions of years. They act as natural telescopes, magnifying the distant universe for us to see. They are jewels of physics, scattered quietly across the velvet night. Finally, consider the idea of endlessness. We are used to boundaries, walls, horizons, edges, but the universe may not have any. Current science suggests that space might be infinite. We can only see a certain distance, the observable universe. But beyond that horizon, the cosmos likely continues forever. No edge, no drop-off, no final wall, just more galaxies, more quiet stars, more vast spaces drifting on without end. It is a concept that invites deep rest. There is no cage, no limit, just an infinite, open expanse where thoughts can drift freely, floating on and on into a peaceful, boundless forever. As we drift deeper into this peaceful night, let us consider the invisible rain that falls upon our world. We tend to think of space as empty, but it is actually alive, with tiny travelers every single second. High-energy particles known as cosmic rays are arriving at Earth. They come from the sun, from distant supernovae, and from the deep, mysterious engines of the galaxy. These are protons and atomic fragments that have been accelerated to incredible speeds, sent on a journey across the void. Most of them are gently deflected by Earth's magnetic field, a protective shield that guides them away, but some pass through the atmosphere and reach the surface. It is a strange and beautiful thought. Right now, harmless particles that began their journey in a distant explosion light years ago are passing through the room where you sleep. They are silent messengers, a reminder that we are physically connected to the farthest reaches of the cosmos. Travel back in your mind to the very first moment. There is a concept that is difficult to grasp, yet strangely calming. There may be no such thing as before. We are used to cause and effect, to yesterday and tomorrow. But according to our best understanding of the universe, time itself began at the Big Bang. It was not just an explosion of matter into empty space. It was the unfolding of space and time together. Asking what happened before the Big Bang is a bit like asking what is north of the North Pole. There is nothing there to measure. It is the ultimate starting line. In this view, the universe did not replace something else. It simply began. It created the very concept of now. It is a thought that allows us to let go of the past completely, resting in the simplicity of a universe that just is. In the deep field of the sky, there are objects that once fooled us with their disguises. Decades ago, astronomers found faint points of light that looked exactly like stars, but they were too bright, too energetic, and too far away to be normal suns. We called them quasars. It took years to realize their true nature. They are the brilliant hearts of distant infant galaxies. A quasar is powered by a supermassive black hole feasting on gas, glowing with an intensity that can outshine a trillion stars. They are the lighthouses of the early universe. The light from these objects has traveled for billions of years to reach us, arriving as a tiny, deceptive speck. It is a case of mistaken identity on a grand scale, a ferocious, ancient fire looking like a gentle, twinkling star in our night sky. Our own home is not stationary. We are on a long, slow slide through the dark. The Milky Way, along with Andromeda and our smaller neighbors, forms a local group. And together, we are all drifting. We are moving toward a mysterious gravitational anomaly known as the Great Attractor. And beyond that, the Shapley supercluster. These are vast concentrations of mass hidden behind the dusty plain of our own galaxy. We cannot see them clearly, but we can feel their pull. It is as if the entire neighborhood of galaxies is flowing like a river toward a great, unseen ocean. We do not know exactly what lies at the end of this journey, but we know we are moving together, pulled by the gentle, heavy gravity of unseen giants in the distance. Consider the era we live in. You are alive during the stellar springtime. The universe has seasons, though they last for billions of years. Right now, the cosmos is active. Stars are being born, galaxies are churning, and lights are turning on in the dark. But this was not always the case. For the first few 100 million years, there was only darkness And in the far, far future, the star-forming factories will close down. We are living in the cosmic spring, the golden age of starlight. It is a time rich with energy and creation. It is a privilege to be here now, in this bright, vibrant window of time, bright enough to wonder at the beauty, yet quiet enough to close your eyes and rest. But seasons must change. In the very distant future, the stars will stop being born. Star formation relies on cool clouds of hydrogen gas. Over eons, this fuel gets used up. It gets locked away inside dead stars or blown into the thin, hot void. Billions of years from now, the galaxies will run out of the raw material needed to make new suns. The universe will slowly dim. First, the blue giants will fade, then the yellow suns like ours, and finally, the faint red dwarfs. It will not be a sudden end, but a gentle lowering of the lights. The universe will settle into a long, quiet twilight, populated by the silent remnants of stars, black holes, and white dwarfs cooling in the eternal night. It is not a tragedy. It is simply a peaceful rest after a long, busy day of creation. Finally, remember that what we see is only a fraction of what exists. When you look at a photo of a galaxy, you see the glowing stars and the swirling gas, but this is like seeing only the foam on top of the ocean. The vast majority of matter in the universe is invisible. We call it dark matter. It does not shine, it does not reflect, and it does not block light. We only know it is there because of its gravity. It holds the galaxies together. Without this invisible hand, the Milky Way would spin itself apart. It is a comforting presence, a silent, invisible framework that supports everything we love. It reminds us that the most important things, the things that hold our world together, are often things we cannot see. As we drift deeper into this relaxing nighttime story, let us think about how the universe handles its memories. Light, as it travels, changes. It softens with age, just as we do. When light leaves a galaxy, it begins a journey across the expanding cosmos. But space is not a static road, it is stretching. As the universe grows, it pulls the waves of light along with it, lengthening them. This is a phenomenon known as redshift. Light that began as a bright, energetic burst from a young star billions of years ago is slowly stretched out into a long, lazy wave. It shifts from blue to red, and then into the invisible warmth of infrared. By the time it reaches our telescopes, it is no longer a shout, it is a whisper. It has been softened by the breath of the universe itself. It reminds us that nothing arrives exactly as it left. Everything is shaped by the journey, arriving at the end softer, longer, and more at peace than when it began. There is a theory in physics that sounds like a dream, yet it is taken quite seriously by those who study the nature of reality. It suggests that the universe might be a hologram. This is known as the holographic principle. It arises from the study of black holes, where information seems to be stored on the surface rather than inside the volume. Some physicists wonder if the entire universe works this way. What we perceive as a solid, three-dimensional world with depth, height, and width might actually be a projection from a distant, two-dimensional boundary, like a cinema screen projecting a movie that looks real. Our reality might be a kind of grand, mathematical illusion playing out on the edge of forever. It is a strange thought, but a gentle one. It suggests that the heavy solidity of the world might be lighter than we think, merely a shimmering image floating in the dark. If we were to look closely at the smoothness of space, closer than any microscope could ever see, we might find that it has a texture. To us, space looks like a perfect, smooth sheet. But quantum gravity suggests that if you zoom in to the smallest possible scale, the Planck length, that smoothness breaks down. Space might be granular, made of tiny, discrete units, like the pixels on a screen or grains of sand on a beach too. It might be a foaming, shifting lattice of geometry. We cannot see it, and we likely never will, but it implies that reality is built, piece by piece, from the ground up. Even the emptiness has a structure. Even the void is woven together, a fabric that holds us while we sleep. In the silence of the galaxy, there are stars that spin with dizzying speed, acting as the universe's most precise clocks. These are the millisecond pulsars. They are the crushed cores of ancient stars, city-sized spheres of neutron matter that rotate hundreds of times every single second. Imagine a star spinning faster than a kitchen blender. They beam powerful jets of radiation into the cosmos, sweeping across the sky like the light from a lighthouse. They are incredibly consistent. They tick with such precision that they rival our best atomic clocks. They are the timekeepers of the dark, spinning silently in the void, marking the passage of time with a rhythm that never falters, counting the seconds while the rest of the galaxy drifts slowly by. And what is the ultimate fate of all this motion? The story of the universe does not end with a bang, but with a long, peaceful exhale. Cosmologists used to wonder if the universe would snap back, collapsing in on itself but the evidence now points to a different ending, the big freeze or heat death. It sounds dramatic, but it is actually very quiet. As the universe expands, the galaxies will drift so far apart they can no longer see each other. Star formation will slow down and stop. The lights will go out, one by one. The universe will become colder, darker, and emptier. It is a slow fade into absolute stillness. Over trillions of years, the cosmos will simply settle down to rest. It is the ultimate bedtime, a final, gentle drift into a sleep that lasts forever. But before that quiet end, galaxies have their own way of breathing. At the center of many active galaxies, powerful forces are at work, driven by the energy of new stars and black holes. Vast super winds can blow outward. These are not breezes. They are colossal streams of gas and dust that stretch for tens of thousands of light years. They push material out of the galaxy and into the deep space between. In this way, a galaxy exhales. It sends out clouds of heavy elements, carbon, oxygen, iron, seeding the cosmic web with the ingredients for future planets. A galaxy breathes in gas to make stars and breathes out dust to make worlds. It is a slow, rhythmic cycle of respiration on a scale we can barely imagine. Let us return to the idea of the distant future, to the vision of the endless ocean. Trillions of years from now, the universe will be a place of profound solitude. As the expansion accelerates, every galaxy will be isolated in its own patch of sky. To any observer, observer left, it would look as though they were the only island in an infinite black sea. The stars will have faded to coals. Even the black holes will eventually evaporate into mist. All that will remain is a thin soup of particles drifting through the dark without bumping into one another. It will be a universe without waves, without wind, and without noise. A perfect, undisturbed stillness, a cosmic ocean that has finally become calm, stretching out in all directions, peaceful and still. Finally, consider where we are right now. We might be living in a bubble of quiet. The universe is filled with crowded clusters of galaxies, but between them are the great voids. Some researchers believe that our Milky Way is drifting inside one of these vast, empty regions, a local void. We might be in a relatively underpopulated suburb of the universe, a bubble where there is less matter than average. If this is true, it explains why things seem to be rushing away from us so fast. We are being pulled toward the denser regions outside our bubble. It means we are living in a protected pocket, a quiet clearing in the cosmic forest, safely tucked away from the busy, crowded centers of gravity, drifting gently through our own private patch of the night. As we float deeper into this sleep story, let us drift toward the silent giants of the galaxy. We have spoken of stars that shine, but there are others that exist as pure, invisible force. These are the magnetars. They are a rare type of neutron star, the crushed, city-sized remnants of suns that have long since faded. But they hold a secret, a magnetic field trillions of times stronger than Earth's. The magnetic field of our own planet is gentle. It is just strong enough to guide a compass needle north. A magnetar's field is so intense it defies imagination. It is a star wrapped in invisible armor. These fields are temporary, decaying slowly over the eons, but while they last, they are among the most extreme objects in existence. They are dense, silent, and heavy, spinning in the dark, held together by lines of force that are more powerful than the star's own gravity. They are monuments to memory and magnetism, solitary anchors in the sea of night. The universe also holds structures so large they challenge our ability to comprehend scale. In 2013, astronomers found something that should not exist. It is a chain of quasars, those bright, active galactic cores, stretching over 4 billion light-years across the sky. It is called the Large Quasar Group. Current theories suggest the universe should be smooth and uniform on such a massive scale, like a calm sea. But this structure is a ripple, a pattern larger than the theoretical limit allows. It suggests that the galaxies are not just scattered pebbles, they are connected. Whether it is a trick of statistics or a true physical backbone of the cosmos, it reminds us that the universe is woven together in ways we are still learning to see. It is a grand, silent tapestry stretching across the deep. Gravity, too, is an artist, and it paints with the geometry of space and time. We often think of a black hole as a trap, but it is also a shape. As you approach the event horizon, space begins to curve inward, and time begins to slow down. To an observer watching from far away, time near the black hole seems to crawl to a halt. It creates a funnel in the fabric of reality. At the very edge, the directions of the universe switch roles. Inward, becomes a direction in time, a future you are inevitably moving toward. It is a place where the rules of the day do not apply, where the rushing river of time slows into a deep, still pool. It is the ultimate stillness, a place where the universe pauses and holds its breath. And as the universe breathes, it grows. This growth is slowly separating the islands of light because the expansion of space is accelerating. There are regions of the cosmos that are moving away from us faster than the speed of light. This is not a violation of physics. Nothing is moving through space that fast, but space itself is swelling between us. This means there are galaxies whose light will never reach us again. We are slowly losing contact with the farthest edges of reality. Each galaxy is becoming a solitary island, surrounded by a widening ocean of quiet dark. It is a peaceful isolation. The universe is not breaking. It is simply growing calmer, creating more room for silence between the stars. Look down for a moment at your own hand. If you are wearing a gold ring, you are wearing a piece of stardust born from a cosmic catastrophe. Gold is a rare element. An ordinary star cannot create it. To make gold, the universe requires the most extreme conditions imaginable, the collision of two neutron stars. In that brief, intense moment of impact, atomic nuclei are smashed together, forging heavy, precious elements like gold, platinum, and uranium. These atoms are then scattered into the void, drifting for billions of years before settling into a cloud that would become our world. Every fleck of gold is a quiet souvenir from a stellar collision. It is a heavy, cool metal that was forged in fire, a tiny piece of ancient history resting gently against your skin. As light travels to us from these distant events, the universe stretches it, like pulling taffy. When we see a galaxy far away, we are seeing light that is tired. It has traveled for so long through expanding space that the light waves themselves have been stretched out. They shift toward the red end of the spectrum. This is cosmological redshift. The light hasn't lost energy by hitting anything. The road it traveled simply got longer while it was walking. It is a silent record of the universe's expansion. The light arrives softer and longer than when it left. It is the universe stretching the signal, a visual echo of the cosmos, taking a deep, steady breath that has lasted for billions of years. Finally, for this part of our sleep story, imagine that sound can be frozen. In the very early universe, before there were stars, the cosmos was a hot, dense soup of plasma. Sound waves rippled through this fluid, pressure waves created by gravity. As the universe expanded and cooled, these waves froze in place. They left a permanent imprint on where the galaxies would eventually form. Today, we can see this pattern in the sky. Galaxies tend to be spaced apart by a specific distance, a cosmic rhythm preserved in stone and star. These are called baryon acoustic oscillations. They are the fossils of the universe's first sounds. A song that rang out before the Earth existed, now frozen into the very structure of the night, holding the galaxies in a quiet, eternal harmony. In the immense, slow-moving river of time, galaxies do not always float alone. Sometimes they merge. It is a process often called galactic cannibalism, but the reality is far more gentle and elegant than the name suggests. It is a slow, cosmic blending. When a smaller galaxy drifts too close to a larger one, gravity begins to unravel it. The stars are pulled into long, beautiful ribbons known as stellar streams. These streams arc gracefully through the sky, wrapping around the larger galaxy like a ribbon around a gift. We see these remnants around our own Milky Way, ghostly rivers of stars that were once independent systems. It is not a violent destruction, but a quiet absorption. One system fades into another, adding its light to the greater whole, leaving only a soft ripple in the stars to show where it once began. Look closely at the night sky, and you might notice that some stars are breathing. Not every star shines with a steady, unmoving light. There are variable stars that flicker like fireflies in the dark. They dim and brighten in a steady, rhythmic cycle. Some pulse every few hours. Others take months or years to complete a single breath. These changes are caused by internal pressure waves, causing the star to swell and shrink. To astronomers, they are useful tools for measuring distance. But to us, simply watching them, they are celestial clocks. They are the heartbeat of the galaxy, pulsing softly in the silence, reminding us that even the stars have a rhythm of rest and activity. In the deep spaces between the stars, there are solitary wanderers. We usually think of black holes as anchors in the center of galaxies, but some have broken free. A black hole can be ejected from its home by the gravitational recoil of a merger or a collision. Once released, it becomes a rogue object. It drifts silently through the interstellar void, carrying no solar system, holding no orbit. It is a traveler of the absolute dark. These wandering giants are invisible and silent, moving through the velvet night without disturbing the peace. They are the ultimate introverts of the cosmos, drifting through the endless quiet, content in their solitude. Sometimes, the force that sends a black hole on its journey is a kick from the universe itself. When two black holes merge, they send out gravitational waves. If the merger is not perfectly symmetrical, it can give the newly formed black hole a kick, a powerful push that sends it hurling through space at incredible speeds. It is like a cosmic recoil. These kicked black holes might leave their galaxies entirely, doomed, or perhaps freed to drift in the vast, empty spaces between the galactic islands. They are silent travelers, pushed by the memory of their own creation. It serves as a reminder that even the heaviest, most anchored objects in the universe can be moved by the right kind of wave. When a star like our sun eventually retires, it may leave behind a treasure. After a star sheds its outer layers, what remains is a white dwarf, a dense, hot core. As this core cools over billions of years, the carbon inside it can crystallize under the immense pressure of gravity. In essence, the star turns into a diamond. These are stellar diamonds, the size of the Earth, but heavy as a sun. They sit in the dark, glowing faintly with stored heat. Astronomers have even detected vibrations in some white dwarfs that suggest they ring like a giant bell. It is a beautiful image, a cooling jewel floating in the silence, a diamond made of ancient fire, waiting in the dark. We often feel like the universe is incredibly old, but in the grand scheme of things, The party has only just started. If you imagine the entire lifespan of the universe, stretching trillions of years into the future, we are currently living in the very first moments of the morning. We are in the stellar spring. Stars are still forming. Galaxies are still coming together, and the universe is bright and active. In the far, far future, the stars will fade and the cold will settle in. But that long winter has not yet begun. Right now, we are living in the golden hour. It is a brief, beautiful season of light and motion. We are lucky to be here now, awake to witness the universe while it is still young and full of energy. When a massive star does say goodbye, its farewell can last for thousands of years. A supernova is a quick flash, but the aftermath is a slow, blossoming flower of gas. The shockwave from the explosion expands outward for millennia, sweeping up dust and gas into beautiful, intricate shells called supernova remnants. They glow in soft colors, pinks, greens, and blues, marking the spot where a star once lived. The Crab Nebula is one such remnant, a cloud that is still expanding from an explosion seen on Earth nearly 1,000 years ago. It is the slow exhalation of a star, a final, beautiful breath that unfolds gently across the centuries. Sometimes, a tiny world can reveal itself just by bending the light. We know that massive galaxy clusters bend light, but even a single planet can do it. If a planet passes precisely in front of a distant star, its gravity acts like a tiny lens. It briefly magnifies the starlight, causing it to brighten and then fade. This is called microlensing. It is a very subtle effect, a fleeting twinkle that tells us, "I am here." The planet might be dark, cold, and far too small to see, but its gravity leaves a fingerprint on the light. It is a gentle reminder that even small things can twist the path of the light, making their presence known in the dark. Finally, imagine the color of the beginning. Long ago, shortly after the Big Bang, the universe was not black. It was a hot, dense fog. But as it cooled to a specific temperature, about 3,000 degrees, atoms formed, and the fog cleared. At that moment, if you could have looked around, the entire universe would have been glowing with a soft, warm orange light. It was like living inside a fire or a sunset. Over billions of years, the expansion of space has stretched that light into the invisible microwaves we see today. But once, the cosmos was a warm, radiant chamber. We were born from a universe that began in a gentle, glowing orange warmth before settling into the peaceful dark we know tonight. As we enter the final moments of our journey, imagine a fire that has burned down low, a quiet ember fading into time. The universe is cooling down, but it does not do so evenly. It is not like a machine being switched off. It is more like a landscape at twilight. Some parts of the cosmos are cooling faster than others. In the vast, empty voids, the temperature drops quickly. But in the dense clusters of galaxies, hot gas remains warm, holding onto its heat for billions of years, like a stone that holds the warmth of the sun after sunset. The universe cools like weather, uneven, textured, and organic. There are warm pockets and cool breezes, local variations in the great, slow settling of the night. It is a system that is quietly alive, finding its own comfortable temperature as it expands into the dark. There is a theory floating on the edge of science and dreams that suggests our universe might be a mother. Some cosmologists wonder if new universes could be born from our own. They speculate that through quantum fluctuations or the mysterious physics inside black holes, a new reality could bud off like a soap bubble, drifting away from a larger one. If this happens, it would likely be far beyond our reach, hidden behind the veil of a black hole's event horizon. We may never see it, but the idea is beautiful. It suggests that the darkness is not just an end, it is a womb. Somewhere in the deepest silence of space, a new Big Bang might be blooming, a fresh start hidden inside an ancient ending, a whisper of something new inside the silence of the old. And though it seems quiet now, the cosmos is still humming a very old tune. In the first fraction of a second, during the rapid expansion known as inflation, the universe rang like a bell. That initial burst of energy sent ripples through the fabric of reality, primordial gravitational waves. These are not sounds that travel through air, but tremors in space-time itself. They stretched across the cosmos, becoming the seeds for the galaxies we see today. The universe still carries this vibration. It is a faint, rhythmic pulse, a background hum that has persisted for 13.8 billion years. It is the memory of the first moment, a soft resonance that underpins the silence, holding everything in a subtle, invisible harmony. Finally, consider the most profound fact of all. The universe is vast, but it is not separate from you. You are, quite literally, made of stardust. The carbon in your cells, the calcium in your bones, the iron in your blood, all of these atoms were forged in the hearts of ancient stars that lived and died billions of years ago. They were scattered across the galaxy, gathered into a cloud, and eventually formed the Earth. And then you are the universe made conscious. You are a collection of atoms that has come together to look up at the sky and wonder. Through your eyes, the universe sees itself. Through your dreams, the universe imagines. You are a flicker of awareness in the vast theater of space, a way for the cosmos to know its own beauty. And now, our journey is complete. Thank you for spending this quiet time here, floating through the mysteries of the deep. We have traveled across light years, past the swirling storms of Jupiter, through the diamond hearts of stars, and to the very edges of time itself. But now, the traveling is done. The stars are staying in their courses. The galaxies are continuing their slow, graceful drift. There is nothing more you need to understand, nothing more you need to learn tonight. Take a moment to feel the stillness in your own room. Feel the gentle weight of your body sinking into the bed. Your breathing is slow and steady, matching the slow, rhythmic expansion of the universe itself. You are part of this vast piece. The same gravity that holds the moon in the sky is holding you safely here. You are made of light, and you are returning to rest. If you are still awake and wish to continue drifting, there are other stories here for you. But if your eyes are heavy, simply let go. The stars will still be there tomorrow. For now, there is only the quiet, and there is sleep